Okay guys, welcome back to another episode of Chaos Chem. Sorry it's a little early in the day yet. Only had one cup of coffee. Okay, so today what we're going to be doing is we're going to be making potassium iodide. And this combined together with the lead nitrate that I showed you how to make in the last video, we are going to be making what is called lead iodide. And like I said before, it's not really that useful of a chemical. It is just very pretty to look at, so I figured I would show you how to make it. Okay, so the first thing we need here is we need 2 beakers. I'm going to grab those right now. And then we need our reagents, first of which is a very easily obtained reagent, just potassium hydroxide. Second of which, however, is a little bit more exotic, and that is the elemental iodine. You can see here how it has discolored my container. This container started out with a white lid. Iodine just does that. It's part of the beauty of iodine. So I guess I should make the disclaimer here that this is in no way, shape, or form a cost-effective means of making potassium iodide because the iodine itself is rather expensive. However, I just wanted to show you how to make it in case you're interested. Potassium iodide can be bought online from pretty much any source that you can buy chemicals from, and it is a rather cheap reagent. So this is basically just a demo video. If you ever do want to make it, you know how. However, like I said, I would just recommend just buying it directly. Okay, so now we have to weigh out our reagents. And what we need here to have fairly stoichiometric amounts is we are going for 2.5 grams. Oh no, my batteries are dead. Time to switch batteries here, guys. Bear with me for a second. What did I do with my batteries? Okay, so we got the battery changed out. I finally found what I did with my batteries. And so, let's go back to measuring our reagents here. Again, I said we need 2.5 grams of iodine. And now, these measurements are not entirely stoichiometric. What we are doing is actually adding a slight excess of iodine. Oop. A little overboard there. A little too overboard. 2.6. There we have 2.46. That is close enough to 2.5 because, like I just said, we are actually putting the iodine in excess. This is going to be just a little bit less of an excess than what I wanted to start with, but that's okay. It is still in excess nonetheless. And now we need 2 grams of our potassium hydroxide. So we got 2.03. It's plenty close enough. That means we're only 3/100ths of a gram heavy. So that is fine. Let's turn our scale off, get it out of the way. It'd help if we put the battery cover back on, but we can do that later on. You guys don't need to see that. Okay, so the next thing we need to do is get our distilled water. And what we want to do is we want to get 100 milliliters of distilled water. I'm just using the graduations on the beaker because this does not need to be completely precise for this reaction. And then we put in our potassium hydroxide. And so the next thing we want to do is we want to get this into solution. So we come over here to this hot plate. If you're wondering why I have several, it is because I have had them break over the years. So this hot plate here does not actually heat up, it just simply stirs. So what we do is we drop in our stir bar and we turn on our stirring and we simply just wait for the solution to become clear, and so that we do not have any more solids at the bottom. And that has happened pretty much already. You can see here we've got a nice clear solution. There is a tiny little bit of impurity floating in there. That must have been from something that was in the beaker that I did not wash out thoroughly enough. So let's go ahead and get that out right now. A good way to do that, when I'm just floating on the surface, is just to simply take a paper towel and kind of use it just to skim the surface off. There we go, now we got it. Not sure what that was, but it was obviously something that I did not wash out good enough. Okay, so the next step is then to into our potassium hydroxide solution. We want to turn the stirring back on. And you want to have it on the lowest setting you possibly can. If you do not have a magnetic stir plate, this can obviously be done by manual stirring. So then we add in our iodine. And again, we want to stir this. We can turn the stirring up a little bit. What we want to have happen here is we want the iodine. You can see it's moving around the flask. Turn it up just a little more. And so there you can see it. You want the iodine to be freely moving around the flask. And we just let that go until all of the iodine has dissolved. As a matter of fact, just to speed this process up, I think I'm going to transfer this to another hot plate and put a little bit of heat to it. Okay, so I have transferred it back to my hot plate that actually works. As you can see, the color of the solution has turned a nice yellow color. You can still see some of the iodine floating around down at the bottom. I've just put this watch plate on top of it to keep anything from splashing out. And so what we want to do is just simply wait for all of our iodine to go away. You might be wondering what the yellow color is. The yellow color is actually potassium iodide, and that is basically a side product in this reaction. However, when we go to filter it, the potassium iodide will essentially be trapped in the filter paper, leaving a solution of potassium iodide. So now we just wait for our iodine to completely dissolve with heating to expedite the process. And once that is all the way dissolved, I will come back and show you what it looks like. Alright guys, so you can see here our solution is, better turn the heat off before we take our water vessel off of here. So you can see our solution is now pretty much a clear color. The yellow has gone away. You see my stir bar down in there. The next step then is we need to cool this down. And this can be done in two ways. You can simply stick it into an ice bath, or you can opt to do what I am going to do, and that is just to stick it in the refrigerator for a little while. However, I do have a dedicated laboratory fridge. If your mom and dad or whoever is going to bitch about you sticking this in the fridge with food, even though this is a fairly non-toxic solution and it is not volatile, meaning there won't be gases produced into your fridge, then I would recommend saving yourself the headache and argument and just going ahead and sticking this into an ice bath. However, before we do that, we want to remove our stir bar, and the easiest way I found to do that is you take your trusty magnet. Oop, there we go. Stir bar's out. Now, since our glassware here is relative, well, this isn't actually that hot. I can grab a hold of it like this and hang on to it for a while, so we're probably right at around the 90 degrees Celsius mark. And I'll just use my non-contact thermometer here to check that, see how close of an estimation I am. Oh wow, I was actually very, very high. This is only at 62°C, which is still pretty hot. It's about 140 degrees Fahrenheit. So roughly this is about like touching a hot pizza after it's come out of the oven and cooled down for a little bit. So I think this is probably cool enough that we can stick it into the fridge and not have to worry about thermic shock breaking the glass. If you're going to be immersing this in an ice bath, I would recommend letting it cool down to room temperature before doing so, because the difference in temperature is going to be so great that you inevitably will crack the glass. Even if you are using a borosilicate beaker such as this, it has a low coefficient for thermal expansion. You still don't want to risk breaking your beaker, so wait for it to cool to room temperature first. I'm going to stick this in the fridge now though, however, because mine is cool enough. And then we will filter it off after it is cooled down. Okay guys, we're back here. Our solution has been cooling I left it in the fridge for about an hour. And we can see that nothing really precipitated out. There is, however, a slight little film here at the bottom. Can't really see it on camera. However, it is there. So, in able to get rid of that, we are going to do a simple gravity filtration. And I am just using a gravity filtration here because we just want to get those impurities out. Since we have such a non-viscous fluid here, it will go through the filter paper quite quickly. As you can see, it is just flowing out quite nicely. And so once this is done filtering, then what we need to do is we need to actually heat it up to precipitate out our potassium iodide. So our solution is done filtering. What that did was that took out the potassium iodate. So now, as I said, we just need to heat this up until we see crystals precipitate out of it. The reason I'm transferring this back into the small beaker is because this beaker here is actually just for doing filtrations into. Has a crack in the bottom of it, so heating it is not the best thing in the world to be doing. In fact, it would just shatter the glass. Now, in boiling this, it's going to produce something that is called bumping. And that occurs in certain substances when you are boiling them. It creates huge air pockets that as they release, it actually will kind of bump your glassware up off the hot plate. So to get around that, what we need to do is we need to put in some boiling chips. And boiling chips are nothing more than, in this instance, just some pieces of glass. This is actually borosilicate glass from a beaker that broke. And we just drop a couple pieces in there. And so what that does is that allows the air bubbles to sort of catch onto this glass and form smaller bubbles so that we don't get these huge bubbles just releasing all at one time. And these boiling chips then, since they are producing it or creating smaller bubbles out of one big bubble, that reduces the bumping effect. So the boiling chips are pretty much a necessity for this part of the synthesis. Again, all they are is just essentially broken pieces of glass. They do make specific boiling chips. However, there is no need to buy them because the solution that we are boiling here is not corrosive. It is not a heavy oxidizer. So we do not need to worry about any specialty chips. You can just use the broken glass. And I'm just going to turn this up onto high and let it go. And so what we want to do here is we want to let this boil. And once the fluid reduces down so much, we will start to see a white precipitate fall out. And that precipitate is our target product. That is our potassium iodide. So I will let this boil, and once the precipitate starts to come out, I will come back and show you what that looks like. Okay, so you can see here, you hear that noise? That is the bumping occurring. And you can see the pieces of glass being moved around in there. If we did not have those pieces of glass in there, our beaker would literally be bumped right off the hot plate. And you know, I think I'm going to add in a couple more pieces of glass, because even though I have those chips in there, it's still bumping rather rigorously. And I don't want to lose our solution off the hot plate, so let me just add a couple more pieces of glass there. So I added about 3 more pieces of glass, or boiling chips, to the solution. And you can see it is still bumping rather vigorously. And at this point, there is not much we can do about that. We just have to watch our solution very carefully and make sure that it does not slide off of our hot plate. Okay, so we boiled down our liquid. You can see there, that's all that's left. And we can kind of see a white powder floating in there. You can see it better if I come from the top. That white powder is our target chemical. That is our potassium iodide. Now, since this was just a how-to video, I did not make enough to even really be recoverable. If I were to recover this, I would have to boil down almost all of the fluid just to get it out. However, when you guys make this at home, if you do, I would suggest ramping up the scale on which you make it, and then you'll be able to recover it. And you just do so by putting it through a gravity filtration and then scraping it off the filter paper and letting it dry in the air. So that's all there is to make potassium iodide. Hope you guys enjoyed. If you really like these videos, check out my Patreon page. You can support me in the production of these videos on there if you so choose. Later on.